So today's question revolves again, I think we had one earlier in the week, around 240 volt power. And as most of us know, in North America, we use 120 volts. In Japan, we use 100 volts. In Taiwan, 100 volts. And in the rest of the world, it's either 220, 230, or 240. And we're kind of the outliers in this sort of thing. So the question here comes from Poland, Warsaw, Poland, Dominic. And Dominic writes, "Hey Paul, how can you design and test 220 volt units without 220 volt current in the walls? Do you use a simple transformer or complicated devices to get 220 volts in your factory? Do you find any sonic differences between the 110 and the 220 volt units? Best regards, Dominic." That's a really good question. I don't think anybody's ever asked it. It's one of the things I just love about this series, whether you're listening to it on Ohm's Law or Ask Paul. I am asked all the time great questions by our customers, and they're questions I would never have thought to ask, and consequently never decide to answer them. If you don't ask it, you can't answer it. I do apologize to a number of you. I have now collected almost 500 questions, and if I do one a day, well, you do the math. But I try and go through. There's a lot of duplicates, so and I apologize if you've asked a question and I haven't answered it. You have my apologies, but you can see the problem. But don't stop sending them, because I read every one of them. Sometimes I personally respond to them because they need an immediate response. But generally, I go through them, find the best ones that I think would be of interest to our audience. So, how does PS Audio create 220 volts to test our equipment? Well, let me tell you something interesting. If you live in the United States or Japan or Taiwan, you actually have 220 volts coming into your house, right? Now, a lot of people, if you think about it, you'll probably think, oh, yeah, like what my stove plugs into. Right. Or your dryer, if you have an electric dryer, those all run at the higher 220, 230 volts, and they have special plugs for those that your electrician hooks up. So the simple answer is, you know what? You've already got it coming into your house. You don't need anything special other than to hire an electrician, put a special plug in. But why would you do that? We do it here because we have to test everything. And I'll show you what we use. Now we have what's called, into this building, it's a fairly big building, we have what's called three-phase power. So there's quite a bit of power and voltage coming into this place, and we have multiple circuits that service it, and we can choose what voltage we want. But because testing of 230 volts that we send overseas is so important to us that we get it right, we want to make sure that the 230 volts that we get is really clean and is relatively identical to what you find in Europe in all respects except frequency. So we'll talk about that in a sec. So look at this thing. Now, apologies to Ohm's Law listeners on the podcast because you're not looking at it, but I am looking at something that is about the size of a dishwasher. And this giant beast right here is a massive transformer. I don't know how big it is. Let's see if I can even read. I mean, it's big. Well, it's, let's see. Whew. Well, it doesn't actually say, but I think we probably dropped $12,000, $15,000 into this thing. Just imagine something the size of a dishwasher. Inside of this is a huge transformer. So we can run, and then we run 230 volt lines throughout the building. So in test, in engineering, and in production, there are 230 volt, 220 volt lines all separately plumbed in so that our technicians and our production people can easily test out the equipment. One of the differences between Europe and most of the world and the US and the 120 volt countries is the frequency that we use. Europeans and many 230 volt countries use 50 hertz. In other words, a sine wave going 50 times a second, as opposed to 60 hertz, which is what the standard is in the United States. Our sine wave moves a little quicker at 60 times a second. This all goes back to some great stories with Tesla and his obsession with threes. Nikola Tesla was a very superstitious man, and everything he did had to be in threes. So there was no way that you're going to do 50 hertz because it wasn't divisible by 3. 60 is, and that's kind of how we wound up with 60. Now, higher frequencies are actually more efficient and smarter than lower, but they have their drawbacks, and regardless of my opinion, no one's going to change the frequency in this country to something that's compatible elsewhere. So we won't even go there. But that's how we do it. And the last part of his question, do they sound different? No, and here's why. Our transformers have what we call primaries and secondaries. The primary is the input to a transformer and is what connects directly up to the wall socket in your home. That's where the voltage goes in. The secondary is what comes out of the transformer after it has been transformed from one voltage to another voltage. So if I have 120 volts coming in, I'm going to transform it to the voltage I need, and let's call it 30 volts. Okay, so I have a 4-to-1 reduction that I'm transforming by means of magnetic coupling between the primary and the secondary. If I double the input voltage, I still get a 4 times reduction, so my 30 now jumps to 60 unless I change that ratio. And I do that on the primary by going to a different set of windings. And what comes out of the transformer in a 230 volt country is identical to what comes out in a 120 volt country. So when I'm in Europe, when we go to 230 volt countries, there's no difference in sound. And that's the long and short of it. Great question though. Thank you for asking. I will talk to you tomorrow. Be there or be square. Bye.